Okay guys, welcome back. We are at 4.3, understanding number 5, and we're going to be looking at methanogens. So methanogens are microbes, they're prokaryotes, that produce methane gas from organic matter through methanogenesis. And basically there are going to be 3 groups involved. The ones that we're going to be mostly concerned about is this last one here. So all methanogens are obligatory methane producers. And the reason is basically they create methane to use in a process of cell respiration. So methane is produced from organic matter in an anaerobic, this is very important here, in anaerobic conditions by methanogens. Some of the methane diffuses into the atmosphere and or accumulates into the ground. You already know this. We have methane as one of our greenhouse gases. And we also know that methane is a natural gas. Not only is it cow farts and cow burps and human farts, or flatulence, if you guys want to be a little bit more discreet. It's called natural gas because it occurs naturally. Okay? But we actually use it to do things like you have gas pipe to your house. Often you have fake fireplaces where people are combusting methane gas instead of log gas. You can have gas grills. We use methane gas for quite a lot of things, including replacing coal burning factories with methane gas burning factories. It's significantly cleaner than coal burning factories. However, it too has its downfalls. IB loves methanogens, and one of the ways it loves to talk about methanogens is because it wants you to know where you can find them, and it likes to ask questions about them. So again, we're saying that methane is produced from organic matter in an anaerobic condition. So what you're seeing here is you can see methane being produced. I don't know if you guys have ever seen landfills. Quite often, if they're all nice and green, I mean, I've seen redevelopment of areas, at least I did in Hawaii, where they have the landfills and they cover it with grass and they make it absolutely beautiful. And then they go in and they put in like a really nice park here with some drives, or not drives, but like, places for like little sidewalky areas for people to enjoy the sidewalk. But in that, what you see is they have to have these like creative ways to make vents. So they have to have these vents in the ground because methane gas comes out of the vents. Sorry, that should be CH4. So that they have to have a way of off-gassing the gas that's accumulated from the anaerobic situation, not the aerobic, but the anaerobic situation, meaning there's no oxygen there that's in the ground, and you've got all of this decaying, rotting material of food waste and things like that. So all these bacteria are there, and you have this anaerobic situation of decaying matter. You put green grass over and it's beautiful, but now you need a way of releasing that gas. So in landfills, you can see it. You can see it in the muds and lakes. In fact, in 1776, an Italian scientist was the first person to sort of discover that this bubbling mud right next to some reed beds in Italy, this bubbling mud was actually flammable. So you're having this mud bubble up, and then I don't know why he decided to put a light to it, but when he did, he got fire, and it was explosive. Yeah, so he was the first person to identify the fact that there were pockets of this gas being produced. Another place that you can see this, because it's an anaerobic situation where it occurs, that means it's got to be swampy water, wetlands, is what we're talking about, mud. Well, what crop is grown in swampy, wet water? What do you see people rolling up their pant legs and walking through and collecting? And that would be rice fields. So if you see a rice field on an IB question, and it has something to do with carbon circulation, I promise you need to be talking about the fact that it's producing methane gas. Yeah, that's the same gas that you see when you're looking at these cows. Yeah, and then you got gas coming out of those cows. It's one of the reasons why people are saying we need to stop eating red meat, because when we have these cows, we have the bacteria that live in their guts. They've got 4 stomachs, and it's an anaerobic environment. In fact, they live in human gut too, but we just don't have near as many of them. And so they're tooting all the time, and it's gotten significantly worse because we're feeding them the wrong things. We're feeding them corn, and that causes an even greater buildup of this internal gas by these methanogenic bacteria, these archaean bacteria, and producing even more and more CH4 into the atmosphere. I could argue that that's a closed system in some ways, but the problem is that even though we're not really increasing the number of cows, because we're We're not increasing the number of cows because we're killing them and then we're breeding them and killing them and breeding them. But because they release all of this methane gas in the atmosphere, the problem is it accumulates because it takes 12 years, approximately 12 years for it to break down. It does break down naturally pretty quick. You don't need to know this. It does break down naturally pretty quick. But the fact is that if it takes 12 years, then you're increasing the amount of gas that's accumulating in the atmosphere much faster than you're breaking it down. And so that's one of the reasons to push to stop eating red meat. I can't say I agree with that, though, because it's such a very small amount of greenhouse gas in the atmosphere from that. But if you're a vegetarian and you feel strongly about that, I'm all there to support you. Okay, next we're going to talk about peat. And peat is organic matter that is partially broken down, but then it gets all swampy and it gets too swampy. And so the lovely little spots inside the ground, let's change this color, that you could have our lovely saffrotrophs in there that will help to basically break down the decaying organic matter by externally digesting it. If you recall, they secrete enzymes externally and then they suck it up as it's been liquefied. Well, all of these little gas pockets where you could have these nice saffrotrophs living, don't forget a mushroom is an example of a fruiting body for a saffrotroph. They have hyphae, the hyphae are the saffrotrophs. Well, they can't survive if it's completely wet, so they die. So the whole in this peat, this partially decayed organic matter is in an anaerobic environment. So you have this organic material that is only partially decomposed. Okay, so understanding number 7, peat forms when organic matter is not fully decomposed because of acidic and or anaerobic conditions in waterlogged soil. Another situation is if the soil is too acidic and it's damp, but remember, organisms don't live in highly acidic environments. They live in a pH range that's good for them. So unless they're an extremophile, and saffrotrophs are not an extremophile, they're not going to be living in an acidic environment. So if it becomes highly acidic, you don't have the saffrotrophs growing there. So either it's completely waterlogged and there's no more air pockets anywhere for these saffrotrophs to go, or it's acidic. Either way, you don't have saffrotrophs and you don't have detritivores in there, and you just don't get any breakdown of the organic matter. So it gets compressed on each other over time, and it gets very compressed, and it forms hard dirt-like products that we call peat. So it's compressed, partially decayed organic matter. And you can use this peat, and I don't recommend you do because it smells absolutely disgusting. How do I know that? Because in Ireland, they still have fields of this. Even though it's protected, you can still see people go out and cut bricks of peat. They have like this little cutter. It looks like this, and this is sharp here, and it's like a square, so it's sharp down here, you know, here, and they use that to cut the ground, and it's got a stick here, and they literally just like a shovel, and they push down, and they cut it, and they pull it out, and they knock off a piece of brick out of it, and that's peat, and then they use it to burn. So it is combustible. It's a good fuel. So understanding number 7, again, peat forms when organic matter is not fully decomposed because of acidic and or anaerobic conditions in waterlogged soil. Basically, you can use this peat as a source of energy for heat, but it's kind of stinky. So if we look at what happens to these carbon compounds over time, so carbon and its compounds are very stable and so can remain unchanged in rocks for long periods of time. There are large deposits from past geological in an era, found on Earth. So partially decomposed organic matter from past geological eras, was converted either into coal or into oil and gas that accumulate in porous rocks. So let's talk about what happens. I told you, you have organic matter. It falls down. It's wet and swampy. It keeps dying. More leaves fall on top of it. More leaves fall on top of it. So you create these stacks, and you can see that here. So over time, this organic matter that's exposed to the oxygen, where it can be partially decayed or start being decayed by saffrotrophs and detritivores, if it's not all decayed, it starts to get compressed and compressed and compressed because you keep having new stuff falling on top of it. That's what you have down here is peat. The thing is that over time, and pressure, because this keeps pushing down on top of it, so it keeps pushing down and down and down. The more pressure you have, the more heat you're going to be generating. So the more weight that's on top of each layer of peat is becoming hotter and hotter and hotter. As it becomes hotter, it's changing from peat into coal. And so it's going through various stages until it gets to what we call our anthracite coal. So you have bituminous, you probably heard of bituminous sands. It's one of the things that they can extract coal like, well, it's actually not coal, it's like thick, gooey, oily muck. So it's just before it turns to rock hard coal. But you have these bands, and these are this is the process of peat becoming hardened or lignited to end up becoming coal. And so that happens with pressure and time. So pressure is creating the heat, and it happens, all of that pressure over a period of time is going to take your peat, partially decomposed organic matter, and turn it into solid coal. Okay, it's similar to, but not equal to, oil and natural gas that you find in seabeds and lakes. So for you to find oil, when people drill for oil, that would be because there was once an ocean or a lake there. So it's the same idea. You have all of this matter that keeps decomposing and falling into the ocean, and then it has sediments being laid over it. So you have one layer here, then more decomposing organic matter, and also the fish are dying, and so they die and they fall in, and then you have the little shellfish die and fall in, and then you have all the little algae and stuff up here, they die and fall in, and so layer after layer after layer. You also get porous rock type formations. Limestone is great for that, but you get these porous rock type formations, and those trap oil and they trap natural gas. And it's one of the reasons why you can get fracking, because that natural gas is trapped inside that rock formation. So it's a similar process, but it has water involved with it, because the water is also adding another type of pressure onto these sedimentary layers. So oil and natural gas formed at the bottom of seas and lakes, where decomposition is often not completed. Over time, sediments cause organic matters to be compressed and heated. Chemical changes resulted in mixtures of liquid carbon compounds, and gas accumulate in porous rocks where they're stored. So understanding number 8. Partially decomposed organic matter from past geological eras, there we go, was converted either into coal or oil and gas that accumulate in porous rocks. All right, so chemical changes, we already talked about that. And now, when organic matter is heated in the presence of oxygen, it can ignite and burn. The reactions that occur are called combustion. So you have to understand that we're getting combustion, which is our organic matter in the presence of oxygen. And it's going to be broken down into carbon dioxide and water and energy. That carbon dioxide goes into our atmosphere, as does water. Water is also technically a greenhouse gas, water vapor, but because it rains, we don't really consider it because it's part of a cycle. Okay, so understanding number 9, carbon dioxide is produced by the combustion of biomass and fossilized organic matter. So, coal, oil, and natural gas are forms of fossilized organic matter that can be burned as fuels. When they are combusted, large amounts of carbon dioxide are released into the atmosphere. This is believed to be a primary cause of climate change that is being observed worldwide. Okay, and now I'm going to stop this here because we're going to go into acidification of the ocean. So we'll do one more on 4.3.